CCIEORDIE.COM, I'm Artec, and this is switch 300-115, 1.4, what I call AB, trunking. I added this section for completeness. It's not really specifically covered in the blueprint. Cisco provides a number of means to facilitate trunking between switch ports of different switches, one of which is ISL, or Inter-Switched Link, which I am not going to discuss as it will be eventually deprecated altogether someday, hopefully. If you had 5 VLANs on 2 switches, each numbered 6 through 10 as in the diagram, and port 6 on one switch was attached to port 6 on the neighbor switch, and each port 6 was a VLAN 6 member, you would have communication between the 2 switches only through VLAN 6 on those ports. Likewise for ports 7, 8, 9, and 10 if they were configured the same way. It would therefore require 5 cables between the switches to support each VLAN. This would be a very crude design and not very efficient, or as it is said, this does not scale very well. A trunk allows the passing of multiple VLANs between switches on the port or ports that have been configured as trunks for all VLANs by default or a selection of VLANs. Cisco provides a number of means to facilitate trunking between the switch ports of switches. With a trunk in place, we can now use the ports 6 through 10 reserved for passing VLANs to support hosts on both ends instead, as in this diagram depicting support for VLAN 6 here. However, how will switch 2 know that the frame from switch 1 VLAN 6 is destined for its own VLAN 6 through the trunk? VLAN tagging, or .1Q, is that solution, but that's the next segment. Let's get back to trunking. Cisco provides a mechanism called DTP, or Dynamic Trunking Protocol, to automatically allow ports to become trunks. You could also manually configure the trunk on both ends without the need for DTP. DTP will negotiate a trunk if both sides are set for dynamic desirable, or dynamic desirable on one side and dynamic auto on the other. But it will not form a trunk if both sides are set for dynamic auto because both sides want the other side to make a move, and it won't happen without at least one side being desirable. You can also set one side as trunk and the other to negotiate either desirable or auto, and a trunk will form. Or you can forget all about negotiation by simply using trunk mode on for both sides. This is deterministic and foregoes the negotiation process altogether, and also relieves the trunk of the burden of DTP traffic, as well as a particularly nasty type of attack known as VLAN hopping. It goes without saying that a port set as access will never form a trunk no matter the condition of the other port. You can also set trunking to off as well as no negotiate. Off sets the port back to access, and no negotiate means that the port will not negotiate DTP and will set the operational mode to off. Let's look at an example or two. Config T, interface F0/11. Let's default the interface first. Default interface F0/11, and take a peek at 10.1.1.2 show interface F0/13, which it's attached to, F0/11, switch port to look at the operational state, and it's set for dynamic auto and static access. Control-Shift-6X to get back to core 1, and we'll go to config T, interface F0/11, switch port, trunk, NCAP .1Q, because ISL is still there by default for both 3560s and 3750s, so you have to set .1Q manually. Switch port, mode, dynamic, desirable. Now let's look at the operational state of the switch port. Do show interface F0/11. Do show interface F0/11 switch port. And you can see it's forming a trunk. It's set for dynamic desirable. The real takeaway here is don't use DTP. Set both sides of the trunk to switch port mode trunk, and you will avoid the negotiation issue altogether. I would say that that's the best thing to do for a production network. Thanks very much for watching. See you next time on CCIEORDIE.COM.